In this video, we're going to determine if the improper integral, this improper integral, converges or diverges. Right, so a and p are numbers. They're fixed numbers. Right, so as we saw in the improper integrals examples 1 and 2 in the videos section on Blackboard for our class Blackboard page, the way to evaluate this is to write it as a limit. The limit as r approaches infinity of the integral from a to r. And now I'm going to set up to use the power rule. So I'm going to write this as x to the negative p dx. This is equal to the limit as r approaches infinity. I'm just going to leave the limit as r approaches infinity and evaluate the integral. So remember, if you had the integral of, say, x cubed, you would add 1, divide by that amount. So this would be x to the 3 plus 1, x to the 4th, right? So x to the 4th over 4, otherwise known as x to the 3 plus 1 over 3 plus 1. So you could write it like that. So same thing here. The antiderivative of x to the negative p is x to the negative p plus 1. Divide by that amount. Negative p plus 1. We're going to evaluate from a to r. I'm going to write this as x to the 1 minus p. It's the same thing. Negative p plus 1, as we know, is the same as 1 minus p. Here we have 1 minus p, evaluated from a to r. This is the limit as r approaches infinity. Now I'll evaluate it. Remember that we're doing all of this with respect to x. That's this dx here, right? Okay, so the x is what we put the bounds a and r into. So we have r to the 1 minus p over 1 minus p minus a to the 1 minus p over 1 minus p. All right, so we have that. All right, so now thinking about taking this limit, right, r is the only thing that changes, right? R is the thing that we're seeing what the limit as r approaches infinity is. So we can think of this as, this whole piece here, r doesn't do anything to it. So we can think of this limit as the limit as r approaches infinity of r to the 1 minus p over 1 minus p. Minus, so we'll put this like that. And now this whole thing in red here doesn't get, isn't affected by r as r approaches infinity, so we can just leave this out here. We have a to the 1 minus p over 1 minus p. All right, so there's that. And now since p is a constant, again, r doesn't really affect that. So we could, just like with integrals, we can pop this fraction 1 over 1 minus p out to the front. So this is 1 over 1 minus p times the limit as r approaches infinity of r to the 1 minus p minus, so we think of that. That's the thing we're actually dealing with, is that thing in parentheses there. Then we have a to the 1 minus p over 1 minus p. And so now I want to look at this limit here. And that's really the thing that we're concerned about. So now look at the stipulation that we have here. We're saying we're looking at this integral where p is bigger than 1. So what does that mean? How does that help us? All right, so let's see. If p is bigger than 1, now we could subtract p from both sides. Those cancel, right? That becomes a 0 there. So if p is bigger than 1, then that means we have that. Now we can write this, this means that 1 minus p is negative. It's less than 0. We could also write it like this, 1 minus p, 0. Remember, the alligator mouth opens towards the 0, so we go like that. So these two things here say exactly the same thing. But this one makes more sense to me. To me, that looks like, more like is negative. You can see that 1 minus p is negative. All right, so if 1 minus p is negative, right, so have a look at this, right? If you, like it, negative 3 is negative, right? So that means that negative 3 negative 0 is 0, right? So that means that negative 3, otherwise known as 3, is positive. So that means that negative 1 minus p, we have to flip the sign. Remember, with if you multiply by a negative with the inequalities, you got to flip the sign. So you have something like that. Now, negative 1 minus p, we can write, if you distribute the negative through, that makes p minus 1. So p minus 1 is positive. Now, why do we care about all this? Well, one minus p is negative, right? So we have r, we have this variable r raised to a negative power, right? So think about this, right? If you had x to the negative 3, that means that that's equal to 1 over x to the negative 3, or x cubed. So what this tells us is that this is equal to 1 over 1 minus p. That's just a number. The limit, as r approaches infinity, 1 over r to the p minus 1. And p minus 1 is positive. So this expression that I have here in red, right, this is maybe in previous classes you had things like x to the negative 3, and they said, write this with only positive exponents, and then you would write this as 1 over x cubed. This is, down here, this is only with the positive exponents. P minus 1 is positive. as we said here. Oops. I guess I don't like my R there. There we go. All right, so now think about what happens as r approaches infinity. As r approaches infinity, r to a positive exponent, x to a positive exponent, like x to a positive exponent cubed, right? That gets large, right? So this whole thing here, this goes to 0. This goes to 0, and so we get, this is all just 0 here. Anything times 0 is 0, so all of this is 0. And we're left with this amount here. And so what happens is this thing converges because when we take the improper integral, when we take this improper integral here, when we're assuming that p is bigger than 1, we get a number. We get that number. And so, assuming that p is bigger than 1, the integral from a to infinity, 1 over x to the p, converges. And that's really what we need. I didn't mean to put this part in here. If it converges, find its value. But we can do that still. Here we have that value. Remember that 1 minus p is negative. So that means that p minus 1, so we could write this as a to the 1 minus p over p minus 1. Get rid of that negative. So how did I do that? Remember, 1 minus p is the same as negative p minus 1, then those cancel.